now, and we're going to talk solving linear systems. Solving means finding the answer. Linear means what?
Linear.
Constant rate.
Yeah, a constant rate, or they make a line. That's what linear, if you graph them, they would make a line. And a system means it's more than one equation. Okay, so that's why it's called solving linear systems. Okay, and we have three types of problems that we'll be looking at today. One's called a break-even problem. Break. Uh-oh. Here we go again.
What's happening?
I'm going to fix it.
Don't worry.
First, I have to pause my recording. Okay.
That was wonderful.
Okay.
3, 2, 1,
So-
go.
The three types of problems we're going to be looking at is one's a break-even problem. See, that worked, Miss Andre, to fix it. Break-even problem, which is when you're kind of seeing how much money, how many things you need to sell to make a profit, basically, is what a break-even problem is. And then another one is called, what do they call this type of problem? They call this a viable solution. Viable solution, which we'll talk about. Viable means it makes sense. Okay? Viable solution problem. And then we're going to be looking at the wind or current problems. Wind or current problems, which like if the wind is going this way or the current is going this way and you're trying to swim upstream, how fast are you going, or the airplane's trying to go. And those are the three types of problems you're going to be looking at. There's more types of word problems than those, and you'll look at some more of those. But for right now, that's all we're going to look at. Okay? And then I'm going to give you some steps for solving solving linear systems. Okay, solving linear systems, I should say. Okay. So the first step you need to do is read and understand the problem. Read and understand the problem. And a lot of times that means saying, what is it asking me? What is it asking? And a lot of times you could find what is it asking at the very end of the problem. Okay? At the very end of the problem, they'll always have a question. You know, like, how fast is the airplane going? Or how much money and how many shares need to be sold until we break even? So you kind of want to look at the end and read and understand what the question is saying, because you can't really set out to answer a problem until you know what you're supposed to do with that problem. Okay? Then you have to define variables. Define, because this is an algebra class, you want to define the variables, which means what do the letters stand for, or what am I going to let, what I'm looking for, what letter am I going to let, what the letter I'm looking for equal to, or something like that. 3. Anyone know what step 3 would be?
No.
Solve it.
Not yet. Solve what? Okay, so the step 3 would be to set up a system, right? You can't solve a system until you set up a system, which usually involves 2 equations and 2 variables. Okay? Then you write don't tell me. Don't tell me. Oh, wrong class. Mark, right? And then you solve it. Solve the system. And am I done yet? Verify. And 5, you always want to verify that the answer makes sense. And that's kind of what we'll talk about, a viable solution. Verify that the answer makes sense. finally, 6, you want to state the answer. Okay? So what I mean by that is verify that the answer makes sense. For instance, maybe you are, maybe it says one car starts off at 10 miles an hour and accelerates at a rate of 5 miles an hour per second or something. Another car starts off at 10 miles an hour, accelerates at a rate of 3 miles per hour per second or something like that. When will these two cars have the same speed? Well, it might turn out that they have the same speed when they're both going 700 miles an hour or something like that, okay? Or it might turn out that they're both going the same speed at -3 hours or something. Would either of those answers make sense?
No.
No, okay, so that's a case in which you would want to throw out that answer and say there's no real verifiable solution to this question. And then instead of saying x equals, the difference between a straight up algebra equation problem and a word problem is that you can't just say x equals 5 or y equals 2 or something like that. You'd say they will be going the same speed after 2 hours or something like that. So you have to say in words what the answer to the problem is. All right? So we're going to do one. Aren't we going to do one? We're going to do one. Okay? So I'm going to pause for a minute. Oh, there we go. Now I'm going. Okay? So this is an example of a break-even problem. Typical. They like these on the TCAPs. I like these on tests. A fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Okay, so who could tell me what is the question asking? What's the problem asking? Go ahead, Alex.
How many hats?
Right. Good. Notice that he went right to the end. How many hats must the designer sell to break even? Now the next step is to define a variable. Good. So what are we looking for? Hats. So what should I let a variable be? How about hats? You could call it x and y, but I kind of like to use the letters. Let h equal hats. What? Let h equal number of, that means number. Did you know that? That's not a very good number. Number of hats. Okay? Now I have two things going on here, and I'm going to kind of tell you what we have here. If h is the number of hats, you have two equations. You have one equation that involves the I and E. I is your, or E is your expense. Okay? E is going to be, let E equal expense. And this one's kind of weird in that I kind of have 3 variables, but not really. And I'm going to say let I equal your income, okay? Because in a break-even problem, you want to make the expense equal the income. Okay? So in other words, you're making hats, right? It costs you $4.50 for each hat, but you take in $12.50 from each hat, right? So at some point, you're going to make more money than you're spending, or you're going to make it, and you're going to break even. So that's what they're trying to do, and what you're trying to figure out is when is E going to be equal to I. So first, let's set up an equation for E. Okay? Who can give me the equation for your expenses? How much are you expending to buy these hats? Go ahead. $5.50 what, Nina? Yeah, $5.50. $5.50 per what? Per times H, right?
Yeah.
But you have another expense. What's your other expense, Sarah? Nice. Okay. So you also have a $1,400 in advertising. So a lot of times that'll be like your startup costs or something like that. Like to start a company, you need to spend a certain amount of, like no one's going to know you're selling hats unless you advertise, or unless you buy a hat making supplies or something. So this is like your materials. What's I? Can you tell me what I is?
Oh,
What,
income.
yeah, and what is it in this case? How would I find it? No, not $1,400. How much am I taking in per hat? $12.50, right? And so when these $12.50 per hat. So that, okay, so for each hat it costs you $555.50 per hat plus your $1,400, and that doesn't depend on how many hats you make. That's just your advertising cost plus $12.50. So now I'm going to make those two things equal $550 each. So now I'm in the solving part, right? Equals, so I set up my equations. That's a pretty hard equation. Whoops, I forgot my 1,400. Plus, I'm really using substitution here. I'm substituting income in for expense. 1,400 equals 1,250 H. And then I just solve that. How do I solve that? How do I solve that? You know how to solve that? Go ahead, Danny.
So you subtract 550H?
Nice. I'm going to subtract 550H from both sides?
Yeah.
Good. From both sides, 550H. And I get 1,400. 1,400 equal $7. 7 times H, just 700, right?
Yeah.
H. Now what?
Divide by 7.
Divide by 7. Okay. And I get H equals
200.
H equals 200. So how many hats do I need to sell the break even?
200.
200 hats. So now I've solved the equation. I've answered the question. Okay. Now, just to show you, I think it's kind of interesting just to show you what's going on here. Okay. What I have, oops, the lines are going the wrong way. So what these two equations look like, okay, is you have one that starts at 1,400 and goes up where that's really the slope of that line, right? So this might be your expense, right? 550H, and it's starting over here at 1,400, right? Where your slope is actually the 550. This one, your income line, looks like this. You start down here, and you're going up steeper, right? Because you start with 0 income, and then it goes up steep, and then where those two things cross, right there, there's your 20 hats. 200 hats. Okay, 200 hats. So 200 hats. So up until this point, am I making money or losing money? Because this is your expense, right? And this is your income. Up until this point, my expenses outweigh my income, right? Expense is bigger. So up until this point, I'm losing money. See? After this point, here's my income, right? Here's my expense. If I subtract those two things, not that this is going to be on a test or anything, if I subtract this number minus this number, anyone know what that's called?
Money.
Starts with a P.
Profit.
Very good. That's your profit, okay? Because if you take how much your income is how much you're taking in, right? But you also have to subtract how much you're spending to make that thing, right? And so that's, when I was in college, I delivered pizzas for Domino's, okay? And I would come home sometimes, I was the best pizza delivery guy in the whole freaking state. I mean, I would deliver like 100 pizzas a night, because I would race around in my little Volkswagen, and the guy would give us bonuses if we get, you get past 30 pizzas, you get a bonus. If you get past 50 pizzas, you get a bonus. If you get past 100 pizzas, you get like a double bonus. I would come home sometimes with like $150, you know. But then what I didn't realize is that A, I was using a lot of gas, B, my tires were wearing out, C, I was ruining my car, you know, and stuff like that. So my expenses were probably higher than my income, but I didn't really see it, you know. It was like, so, but that sometimes you gotta be worried. Okay, so that's that type of problem. That's called a break-even problem, right?
I just told me you had a reunion.
Oh, do I have to tell it?
You don't have to tell the whole story, but you just say you had a reunion. with
So
them.
anyway, the viable solution problem.
These are
Okay?
great examples to have in your notes.
Yeah, I would be writing things down. And like we said before, I think we said to this class, when you write stuff down, it kind of helps it stick in your brain a little bit. Okay? So identify the constraints and solutions to a problem. The local zoo is filling two water tanks for the elephant exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons an hour. When will the two tanks have the same amount of water? So, what are you looking for?
Tanks and water. The rate.
Not the rate.
When will that turn out?
When, so, okay, that's what you're looking for. So I'm looking for time, right? And so what I could probably do is let t equal the time when tanks are the same. Or t equals time. Let's just say t equals time. Now I got to set up a couple equations. And they're similar equations to the last equation. So the locus is filled into one water tank has 50 gallons of water, and sometimes it's good to underline numbers, and it's being filled at a constant rate. Oh, we need another variable. We need something else. Someone said, when will the amount of water? So I'm going to let W equal the amount of water. Okay. Need another variable. Amount of water. So who can give me an equation for this one? Water equals what? How much am I starting with? 50. No, 50. No, it has 50 gallons.
Okay.
And it's going up by 10 gallons per hour. You understand where that came from? Okay. The second one says, okay, my water starts where? At 29 gallons, and it's going up by what? 3 gallons per hour. What do I want to see? What am I looking for? What am I looking for? When will they be the same? So what do I do with these two equations? What's going to be true about the water? Hello? What do I do? Dig deep here. What do I do with these two? How do I solve this system equation?
You elimination.
Easier than elimination. I want to see when the two... Yeah, you just take this and you put it in over here, right? Because you're trying to see when those two things are the same. So you go 29 plus 3t equals 50 plus 10t. Right, solve. Who other than these guys on this side of the room? This side of the room's going to answer my question.
Byron.
No, Byron. Can you tell me what I would do first over here?
We're solving for T or W?
Yeah, it's for T. For T. We got rid of the W.
You would go and subtract
Yes?
10 over 2.
Uh,
Subtract
yeah.
3, sorry.
Okay, good.
Over, 'cause it's
Very nice. Okay,
And-
subtract the 3 because it's smaller.
Yeah.
Minus 3t. And I get 29 equals, this goes away, equals 50 plus 7t.
And you minus the 50
Good.
on the other side.
Minus the 50 from the other side.
From both sides, actually.
From the both sides. Okay? And now I have that, I could go down. Okay? So now I have that 7t equals negative 21. Now what?
Now you divide by
Good.
7, which equals negative 3.
Good. Nice. Okay? Why is this not a viable solution?
Because it's a negative number.
Yeah, because can you go back in time? You can't really, because if you start at t equals 0, right? Unless you're traveling faster than the speed of light, you can't go back in time.
So
So,
wouldn't be back in time. You'd just be
Well,
traveling faster.
Speed of light
oh,
is like...
yes, you travel faster than the speed of light. Anyway, we're not going to do that. So
No.
basically, what's happening is one tank is going like this, okay? Start slow, starts low and goes up slower. One tank starts high and goes up faster, right? So that other tank is going like this, and so they're going to intersect back here somewhere, you see? And so that's why not only there is a solution, but the solution is a negative number, so that's called not a viable solution if the answer doesn't make any sense, okay? The last one's easy, and then we're going to give you some time to work. Oh, not more? Yeah, there's more. Very sorry, okay? But we're almost done. It's okay. It only hurts for a little while. All right, so let's find that problem. Let's go on to the next page. Let's look at this grade. This is a really good problem as well. And we'll place that in a new page. So, how many of you guys have flown somewhere far away and then flown back? Where'd you go to? Boston. Was it faster getting to Boston or faster coming back? You don't. It's the same. I think it's a little bit. Where'd you go?
Jet stream.
Oh, what do you mean?
What?
Dallas.
Dallas.
Yeah.
Oh, I think that's about the same.
You have to go east-west.
I think you have to go
Let's go
east-west.
east-west
Yeah.
to catch the jet stream.
Kenya.
Dude.
Can you tell me why you went there?
I'm part of a non-profit organization, and we're going to build a school in Kenya, so we went there to look at the land.
Oh my goodness! Wow, that's pretty cool. So, did it take you longer getting there or longer getting back?
Longer to get back, more flights.
Oh, more flights. Okay, where'd you go, Alex?
I went to Spain.
Did it take you longer to get there or longer to get back?
I think longer there.
Anyway. So, in any case, I'm not talking about daylight savings time and the change in the time zone and stuff, but if you go east-west, there's the jet stream, right? And the jet stream, if you're going to Boston, I think it might be pushing you. And if you're coming back, you're kind of going against the wind. I'm not sure which way the jet stream goes. But going one direction, it's working against you, and going the other way, it's working with you. So
we're
in
talking
this,
about actual air time.
we're talking about time in the air. Yeah. And so a lot of times, it'll be longer flying in one direction than longer flying the other, especially if you're going east-west, because the wind is going to get you. A traveler flies from Charlotte, North Carolina, to Los Angeles, California at the same time. Another traveler, so they're going the same distance, goes from Los Angeles to Charlotte. The airspeed of each plane is the same, okay? The ground speed are shown below, okay? So that's the speed with relation to the ground, okay? So if I looked up in the air and I watched this plane, that's how fast it's going through, passing along ground. What is the airspeed? What is the wind speed? So you're going to set up two variables. Let A equal airspeed. Airspeed. Let W equal wind speed. Let W equal wind speed. Let's try to send up two equations given this inflow. How about someone else? Anyone else? Okay, go ahead, Alex.
So
If you're going with the wind, what does your speed look like?
A plus W.
Good. A plus W when you're going with the wind. Which way am I going A plus W? Which is faster? 550 or 495?
Wait, I got this.
Which one is A plus W? 595 or 495? 595, right? Because it says now the ground speed is 595. If the wind is pushing against you, what's this equation going to be? Go ahead. Sorry. Danny.
Wait, how is it 595? Isn't it 550?
Oh, I'm sorry, 550. Sorry, I was looking at. Got my numbers messed up. Okay, 550. How about going in, when the wind is against you? What does that look like? Well, what does that look like?
190 minus
Caitlin. What's 495? What letters go over here? the W goes here and A goes here, what goes between them? Minus, right? If the wind is against you, it's slowing you down, so it's a minus thing, right? So in one case, the wind is pushing you, so you're going like this plus this. In the other case, the wind is pushing against you, so it's slowing you down. Right? This is a very easy system to solve. How do I solve that system?
Subtract.
All right, subtract. Come on.
I got that.
Easier. What's going to make these W's go away? Add them up. Okay. So I get. Whoops. I don't want that. Okay. I'm going to add them. 2A. This goes away. Equals.
You're eliminating.
Elimination. That's elimination. Elimination. Good. And 550 plus 495 makes 1,000. Does it make 1,000 and something?
1,045.
1,045. Thank you. Okay. Now what? Now what? Divide by 2. Divide by 2. Divide by 2. I get A equals 522.5. What's W? What's W? How would I find W?
You would put the A that you just found and plug it back
Right,
in.
you just plug the A that you just found and plug it back in. So 522.5 goes in there, okay? And so I'm going to subtract 522.5 from 5, and so W equals 550 minus 522.5. What's that?
22.5.
22. 22.5?
27.
27.5, isn't it? I think it's 27. Okay, so that's how you do that type round. What is the airspeed? It's 522.5. So in still air, that's how fast the guy would be going. With the wind, he's going 27. The wind is 27.5, and that's the way you do it. All right. So we're going to.